All right, guys, so this is your week 14 Princeton Review help video. This is page 131, numbers 6 and 7. Okay, so let's go ahead and begin here. For number 6, you could distribute first if you wanted to. It's actually not necessary to do that, though. If you ever have a function and it has a number in the front of it, we'll put C for constant, and you want to take the derivative of this function, well, anytime you have a constant there, basically you could just kind of ignore that. That constant's just going to stay there, and ultimately you're just going to take the derivative of the function itself. It's called the constant multiple rule, and so you could write it like this, basically. So all you have to do is basically just ignore this, leave it there, but ignore it, and just take the derivative of this instead. Now they might ask us to go ahead and simplify it, but let's go ahead and do the work here first. So the derivative of this expression would be 9x to the 8 plus 6x squared, and then this is a constant, so it just goes away. Now if you wanted to, and I don't know if the text wants us to do this or not, but we can go ahead and distribute that now and end up with 9x to the 8th over 3 minus 6x squared over 3, and then we can reduce, right? That becomes negative 3x to the 8th, and that becomes minus 2x squared. Okay, so that's one way to do it, is just to take the derivative of the parts with the x's and leave the constant alone and then distribute at the end. Or you could distribute at the beginning and then take the derivative of that. I think it's easier in this case just to do it the way I showed you. This one's funny. You guys got to understand that pi is a number. And when you take a number and you raise it to a power, guess what you get? You just get a number. And when you take the derivative of a number, the answer is 0. So if I were to tell you guys that y equals pi to the 5th power, then y prime is just 0. So you got to be careful there. I think the temptation might be to apply the power rule to this and get something like 5 pi to the 4th power, but that's not going to work. That's what you do to terms that have x's in them. This is just a number, and so the answer is 0 because that's what the slope of a constant function is. Okay, so now we're going to move on to page 139, and I'm going to do numbers 6 for you and 7. 6 and 7. All right, so what we're being asked to do here is we're being asked to find the derivative of this. Now, there's two ways that we could go about doing this problem. One way is you could multiply this first and then take the derivative, or you could do the product rule, meaning you're going to take the derivative first and treat it like a product rule, and then simplify it afterwards. It doesn't matter necessarily. I think that simplifying it will be a lot easier if we start by multiplying and then do the derivative afterwards. So that's how I'm going to handle the problem, is I'm going to actually multiply first and then I'll take the derivative. But you could have started by doing, like I said, you could do the product rule and therefore start with the derivative, and then after that you're going to have a big long string of stuff that you're going to have to simplify anyway. So I think it'll be easier to go ahead and simplify first. So let's do this. So we do our old FOIL method. You do first times first. You do outer times outer. X times negative x squared would be negative x over x squared. Then you do inner times inner. 1 over x times x squared would be x squared over x. And then you do last times last. So that's going to be negative 1 over x cubed. Now I'm going to simplify these things up a little bit. X over x squared is just 1 over x. X squared over x is just x. And then this one's fine for now. Now if you want to take the derivative of this thing, so I notice I haven't done any calculus yet. I've just simplified it. I just FOILed. Okay. Now I'm going to take the derivative. All right, but before I do, when we take derivatives, we like to have things written with exponents instead of written as fractions like that. So I'm going to rewrite these ones that are fractions to have negative exponents. And then I'm going to go ahead and take the derivative of this. Okay, so the derivative of that is going to be 3x squared. The derivative of that, if I move the negative 1 to the front and multiply it by this negative, I'm going to end up with a positive 1x to the negative 2. Take 1 away from the power, right? The derivative of x is just 1. And then for this one, if I move the 3 to the front, the negative 3, it becomes plus 3x to the negative 4. Okay? And then they'll probably want us to rewrite these a little bit differently. And so in our final answer, I would have it written as 3x squared plus 1 over x squared plus 1 plus 3 over x to the 4th. And personally, I think that's good enough. I'm not too sure what they do in the back of the book for this. They might make this really crazy and try to give everything a common denominator, but I don't know. I don't think that we need to get into all that. It's kind of unnecessary. The point I really wanted to emphasize here is that you have an option: multiply first, then do derivative like I did, or take the derivative first and then simplify at the end. And I just know that the product rule makes things look really messy and big, and I didn't want to start there. I wanted to start simple. All right, this next one here. Now, foiling this out would be way more work than it's worth, quite honestly. So I wouldn't advise that. Multiplying that expression by itself 4 times is going to be a lot of work. So I'm going to not do that. Instead, I'm going to apply the chain rule to just take the derivative of this thing as is. So we have an outer function, and then we have our inner function. And as you guys remember, hopefully, with the chain rule, we do the derivative of the outside multiplied by the derivative of the inside. Okay, so the derivative of the outside is going to be 4 parentheses and then a cube here, and then we leave the inside the way it is here. Now for the derivative of the inside, we're going to do low d high minus high, oops, that's an x, high d low. Draw a line and square below. Okay. Okay, now quite honestly, I'm okay if you want to stop here with this problem. I just don't think that the AP exam is ever going to ask you guys to simplify stuff like this, because it's really just, at that point, they're just testing your knowledge of algebra and taking a lot of time away from you, which you don't have to give on a test like the AP exam. So, but some of you guys have expressed in the past that you like to see how to work this out, and I respect that and admire that. So first of all, I would start by distributing the 1 there, which is just going to give me this, and the x's are going to cancel out, right? I'm going to go ahead and apply this power to the top and the bottom, and then move the 4 up here to the top. So I'm going to end up with 4x cubed over x plus 1 cubed. And then, so now over here I've got 1 over x plus 1 squared. Now luckily, since these things are the same, all I have to do is add their exponents when I multiply these together. So top times top, bottom times bottom will give me 4x cubed over x plus 1 to the 5th. Okay, so that would probably be the simplest answer, and I would assume that with this textbook that we're using here, that would be the answer they have in the back, but once again, I'm not sure. All right, let's go ahead and move on to our next one. All right, next page is 264, and we're doing numbers 5 and 6. Now, at first glance, you might be tempted to use substitution on these because we have an integral problem with parentheses, right? But there's really nothing that was going to work here if you tried u substitution, because if you made this a u, it's not going to cancel that out if you took the derivative and all that. And if you make this a u, well, there's nothing left after that to cancel out. So that's not going to work here. And so basically what I would say here is what we want to do is just simplify these expressions and multiply them out so that we end up with something like this. And then we could just do the basic power rule. So I would start by distributing. That's going to be 2x to the 1/3 power plus, now x to the 1/3 times x, well, what would that be? Well, you would add their powers if you're going to multiply those terms together. So 1/3 plus 1 is going to be 4/3. Excuse me. All right, and then we're going to go ahead and integrate. And when you integrate, you're going to add 1 to the power. And then you divide by that number. However, when we're dealing with fractions, instead of dividing by a fraction, it's easier to multiply by its reciprocal. And we'll do the same thing over here. If I add 1 to this, it becomes x to the 7/3, and we're going to multiply by the reciprocal. And we don't want to forget our plus c. Now the 2 and the 4 here can reduce to be 1/2. So what I'm going to be left with is 3/2 x to the 4/3 plus 3/7 x to the 7/3 plus c. And I'd say that's probably a good place to stop with that one. For number 6, we're going to do something pretty similar. We're going to square this first, and then we're going to go ahead and integrate. So if we take x cubed plus x and square it, that means we're going to multiply it by itself. Okay? So first times first, outer times outer, inner times inner, and last times last. And these two can be combined together, right? X to the 4th plus x to the 4th. So those ones can be written as 2x to the 4th and then from there you're just going to go ahead and integrate it. So add 1 to your power here and divide by that number. Add 1 to the power here and divide by that number. And then finally, same thing here. Don't forget your plus c. Okay, so it's not uncommon where you would want to multiply out everything first before you integrate. All right, so this is page 270. And we're doing number 5. Now, it might help if you guys remember what the derivative of square root of x is. If you want to take the derivative of the square root of x, what you end up with is 1/2 times the square root of x, a little shortcut we talked about a little while back. Okay, now you could do it the long way where you change this into a half power and then do the power rule, but just knowing the shortcut for square roots is pretty helpful a lot of the time. So, since I know that the derivative of square root of x is 1 over the square root of x, well, I see 1 over the square root of x here. And when you see the derivative of something inside of an integral, that's a good indication that that something must be your u. So I know on this problem then that my u is going to be the square root of x. So I'm going to start this problem by saying u equals this. I'm then going to move on to say the derivative of u with respect to x is 1/2 times the square root of x. And then I want to get dx by itself, so I'm going to multiply dx to the other side. And then I want to multiply both sides by 2 square root of x. And when you multiply it on this side, it just cancels out. So this is how we get dx by itself. Then we're going to go ahead and put our integral together with the u substitution now. I'm going to put a u right there. And then I'm going to have times 2 square root of x du Now the square roots of x go away, and the 2 can just come out to the front. And from there, I think I'm going to go ahead and let you guys take over. Okay? And you guys can finish the problem up from there. For number 6, I'm just going to tell you that your u is x cubed, and I'm going to let you guys take over from there. Move on to our last one. This one is on page 290, and we're doing number 9. Honestly, this one I'm going to go ahead and just let you guys go ahead and try to do it, just because it's pretty straightforward. There's nothing special or interesting about the problem. I've noticed a lot of you guys are using calculators sometimes on these Princeton review questions, especially for the definite integrals. And I'm going to encourage you not to do that. You want to do these things by hand. The reason being is because I know you guys can do these things on calculators, but the issue is you're going to need to do it by hand on your actual test. So you want to make sure that you know how to do it. So my only encouragement would be to go ahead and try to do this thing by hand as much as you can. Okay, and then from there we'll call it quits for the day. Anyway, hope that's helpful, and we'll see you guys later.